today my topic is development environments for microservices, and especially the one that we have built at Smartly. And the goal for us has been basically to narrow the gap between a Rails monolith and microservices for the development environment. Because as you grow your number of services, suddenly each manual step starts to add up, and to get the full development environment running, you probably need to go through 30 different steps if you have 30 different services. And especially for our case, we figured out that it's a bad idea to store secrets in Git repositories, so then many of them suddenly needed to copy some passwords or API tokens from our 1Password vault to configuration files so that you could run the service, which was not ideal, and it also meant that not many developers actually went through that hustle, and they just had the services running that they needed for their own environment, and everything else was left out. So that adds an extra step to do if you then want to contribute to some other parts of the system, or you need to perhaps investigate how something works there. And where we started from was, or historically the first thing we made was a Vagrant-based virtual machine that was running our PHP monolith and then some Python and even Node.js code, and had MongoDB database, at one point also Postgres. So it was quite a lot of stuff, and it was also quite easy to mess up. So because the virtual machine also contained state, then people were a bit reluctant to provision it from scratch, which would get you in a consistent state. So you might run some random commands on that machine, which then means that you are in a ever so slightly state from what you're supposed to be in, and you run into weird random errors. When we started our journey into more microservices, we also started using Docker Compose as a separate environment, or basically each service had their own Docker Compose definition for the service itself, the databases it needed, and so on. Which is quite good, except that there was one caveat in our case, that suddenly you had to be running 2 different Linux virtual machines on your laptop to run the Smartly development environment. So with the default settings, you were using like 6 gigabytes of RAM, but I also heard that some teams bumped the limit in or the available memory in Docker so that their stuff would run faster to 4 gigabytes. So that was then consuming in total 8 gigabytes of the probably 16 gigabytes available at that time, because you couldn't buy a Mac laptop with more memory. So that's fairly annoying. And then Chrome probably consumes all the rest you have. And your machine is slower than it should be. So we started to look into alternatives. How could we take a next step forward? Of course, we had our own set of goals and constraints, which might be specific to our environment, or perhaps they are not. I'm not sure. But we thought that we would like to run our development environment on a shared Kubernetes cluster, which would be very similar to the one that we are using for production. And that would then mean that we only need to have one set of configuration, or one set of configuration with some overrides probably for development usage. And we had some overhead in setting up new clusters, or we didn't want to run one cluster for each developer, but we still wanted to have an environment for each developer so that they could work independently, for example, on database migrations. We are using multi-repo, so each service or project has their own repo, which is different than perhaps some other companies, especially the big ones, are using. That's basically just acknowledging the status quo. Our existing tooling is built on that assumption, so our Jenkins is not built so that it would only run tests for the changed parts and recognize which tests need to be run. Our deployment scripts assume that you want to deploy a repo, basically. So changing all that would have been quite a distraction. And then we wanted to have the secrets in each repo for the service, so just so that the teams could work more independently and not have to bug someone with a master key to change them in production. And probably the same solution should also work then for development environment. So basically, you could think of Rails's encrypted secrets, but something that is more framework independent, because we are not just running Rails. We have Node.js and PHP and some others as well running, but it can be more Kubernetes specific, because that's the only environment that we are thinking that we are going to run in foreseeable future, at least as we get the older legacy stuff migrated. So to support this, we thought that we would then build actually we have built already a command line interface to automate these tasks, which we call DevBox. So we are not very good with naming, or at least they are not very imaginative. So you probably can guess what DevBox does. Of course, this conveniently forgets that probably the biggest thing that we need to do to get this development environment running was to migrate our existing PHP monolith from the Vagrant setup to run on Docker, but I wasn't that involved in that process. Plus, this is a Ruby meetup, so we can forget about that. And if you're not familiar with Kubernetes, here's my horrible one-slide explanation of what it's trying to do. So Kubernetes is a container orchestration system. You might need to know for the next slides that pod is a group of one or more containers which Kubernetes starts and manages. And containers are something that run Docker images from a registry. So something that's not running on your own machine, at least that's the usual setup. And then Kubernetes can include some custom environment variables as configuration, or maybe you can choose to use a different entry point than is defined in the Docker image. And then in Kubernetes, there's a load balancer that directs traffic that comes into the cluster to a specific pod via services, and you can have basically everything, or pods, you can have multiple running at the same time, which are then just copies of each other. And this is just simply maybe a few hundred to a 1,000 line of YAML configuration, which is perhaps not that nice to read, but it seems to work quite well. And then if you have this kind of cluster where you're running your stuff, it's not immediately obvious how you should turn it to your development environment. And there are different options, which each their own set of caveats and good sides. So there were basically 3 different options that we thought that could work. Basically being running everything locally on a Minikube or your own Kubernetes cluster, or, well, not a cluster, a Kubernetes instance, because it's a single machine. That's actually, I have wrong emoji there, but it's not quite like production because well, it's running on Kubernetes, but very different cluster than you are using. Still probably better than using Docker Compose though. Feedback cycle could be really good with that, because you can mount, for example, your local folders to the Minikube instance or direct them. So there's at least hope that your Rails environment could, for example, use auto reloading seamlessly with that setup. So that's somewhat important for Rails, as it's a framework that's quite slow to start, but they work around that by reloading code when there are changes. The maintenance, however, would be also distributed, so every developer could do whatever they want with the cluster and break it, and no one could monitor if it's up to date or something. And probably as you're running it on your own laptop, your MacBook fans would be screaming at some point, because you're running, in our case, maybe 30 services, but that could quite easily grow in the future to be much more. Then the second option, a bit more ambitious, that you would run most of the services in the Kubernetes cluster, but then you could take a single service or maybe a few that you develop to run on your local machine, and then direct the traffic between, or proxy the traffic between your machine and the cluster. So that would be basically using telepresence, which is the proxy set up there. And it's a bit more like production, because all the other services are at least running in the Kubernetes environment, and it actually takes all the, for example, environment variables that you need for your service from the Kubernetes environment. So it should work quite well in that sense. Feedback cycle is perhaps not as fast in general as you would have something running locally, but at least you can run stuff in your own machine, use the Docker container there. Again, you can mount stuff for your Docker machine. You just have to write a different set of configuration to have the volumes mapped and so on. But it's possible, and we have done it, so that works. And it's a bit easier to maintain, in the sense that the only thing you need to have locally is the Docker machine. Nice. And your MacBook's fans are happy, or you can use most of the resources on your laptop to do whatever you want instead of running your development environment. So in that sense, I think just having a single service is a great improvement to the entire system locally. Then there would be a third option, just like run everything on Kubernetes. There's a tool that helps you with this, which is called Scaffold by Google. So it certainly gets you a very production-like environment. However, the feedback cycle is a bit of unknown. So when we started this, Scaffold didn't support any kind of file synchronization. They added it conveniently like a month or two later, when we had already something working. So we didn't investigate that further, but they have basically, system is that you can develop something locally, and then Scaffold will either synchronize the files to the cluster, or it might push images to a repository, so that you then run that or update the image on a running container, which probably makes sense for Google if they are running, for example, Go-based services, where you have to have the compilation step there anyway. And in terms of maintenance, that should be a fairly simple solution, because you can't even mess up your Docker instance on your Mac because you run out of the 64 gigabits of space that it has available by default. And it's very easy for your laptop again, so you don't need much resources to run this system. But so as you might guess, we went with the telepresence setup as it was available at the time, but also partially because it didn't require us to change anything in our existing setup. So Google Scaffold basically seems to require Helm if you want to use any kind of templating in your Kubernetes configurations, and we had chosen Shopify's Kubernetes deploy as our Helm-like deployment system. And here's a simple image on like how Kubernetes works, how telepresence works. So it replaces your pod in the cluster with its own proxying pod that takes in all the traffic, but also then it allows you to tunnel or your container networking traffic from your local laptop to the Kubernetes cluster. So if you have your, let's say, Rails application running on your laptop in a Docker container and there's a telepresence network set up, then the Rails application can access the Postgres database or whatever databases you have running in the Kubernetes environment, just like the pod could access from the cluster. So that enables us to have a fairly seamless development experience. So when we deploy something, what's happening there in our setup? So we first of all need to build a Docker image, push it to registry. In development mode, we might need to also create a namespace with a user prefix. So if I'm deploying first time a service, then the namespace perhaps doesn't exist, or most likely doesn't exist. So we have this schema where it's prefixed by each one's identity, which they can choose. In my case, it would be Lautis, and then I'd be running stuff in Lautis service name, for example. And that namespace also needs some configuration for Kubernetes deploy to be able to decrypt secrets. So that needs to be synced when the namespace is created. Then during deployment, those secrets must indeed be decrypted in the repo so that you get the correct API tokens and so on available to your application. And as the last step, sync those YAML files from your local repository to remote cluster. And basically, Kubernetes deploy, which we already use, handles the two latter steps rather well. So that we get as a freebie, and we can just call that from our own tooling. But we need to have some system that builds the image and creates namespace or prepares the namespace to be able to run the decryption. And the keys we store in 1Password, so they have a command line client that we can wire up together. So that gets us a devbox deploy command, or how it logically works. Having that running, making a deploy all command is not really rocket science. So you basically need to just run the command on each service or repository. Though that might be a extra thing we need to solve. So we needed to also have a devbox pull command, which would clone and pull all Git repositories to your local machine in a same directory. And of course, doing this deploy all, it was quite quickly obvious that caching was essential. So you don't want to build Docker images for all of your 30 or so services when you first time deploy something. That would be really painful and slow. So having these images stored in a remote registry before you do is very essential. And then we also can parallelize this process, so we can run deployments for multiple services at the same time, which gets us from maybe, let's say, 30 minutes of deployment time to 3 minutes of deployment time for our complete environment from pretty much scratch. And in addition to those things, there is some minor little things that we needed to add. So have some information about pod statuses, an easy way to access logs and so on, and then you get a rather well-working dev box. But this is a Ruby meetup, so how would you build this in Ruby? Because that's what we did. We didn't start with Clamp. We originally built it by hand, thinking that we could make it as a no gem dependency project, which would be nice for distribution. But eventually, it was quite obvious that having a good structure is really helpful, and using Clamp gives us many nice things for free. So the basic functionality is that Clamp passes command line arguments and options, and then runs some commands that you defined as or subclasses of Clamp command. And those can then be built as a subcommand. So like, for example, devbox deploy, or maybe if you're using git pull would be a subcommand. Or you could have any number of layers there, but that quickly becomes quite inconvenient. But it works. And because Clamp knows of the structure of the application, it can help you if you don't know what you're doing. So you can say -- help, and it will print a rather nice looking help output. Unfortunately, man pages are not, at least yet, generated, but that would be a like ideal situation. No one could complain anymore. But I would certainly recommend Clamp as a good baseline for building command line applications in Ruby. But basically what the devbox tool does is just it executes a lot of shell commands, so wiring those together, and that's the glue between one password command line, Docker, occasionally some kubectl or Kubernetes deploy, which we run as a shell command, even if it's a Ruby gem. But that's pretty much most of the functionality. One thing Ruby is perhaps not ideal is the distribution. So there's not that many popular Ruby applications that you could install, for example, from Homebrew or some other package manager, and it would just work. So the examples are a bit limited on how to distribute this, especially on multiple different systems. Of course, gems would be the obvious choice. If you have a working Ruby, you can say gem install. Rails has a command line interface, and it works. There's just tiny little issue there with something like devbox. If you are using multiple Ruby versions in your different services, you need to also ensure that you install the client to all of those Ruby versions and keep it up to date to be able to run the command in all directories. bundler might also interfere with your, or prevent the application from calling debbox in some cases, because the bundler environment ensures that you can only use the specific set of gems available for your application that you define in your gem file. A slightly funnier option, at least, would be to use Ruby Packer, which is a tool that compiles Ruby and your gem, or well, any Ruby application really, to a fat binary that contains everything, which could be great for applications like debbox. But there are some caveats. So for example, file system access is not exactly like you would maybe assume that it is, because the application is now a, well, it's a zip file and then a small piece of code that loads stuff from the zip file. So if you need to give references to any file that's in your application bundle or in the fat binary, then it most likely won't work in the other application. And for example, in our case, Kubernetes deploy wouldn't work without fairly ugly monkey patches to change stuff and copy files to temp files and overriding paths so that Kubernetes deploy would be happy. So what we chose to use then is homebrew formula. You start from a Ruby gem in this process, have a formula that builds and installs gem and its dependencies to a separate directory from your usual gem path, and then have a wrapper script that just manipulates the environment to include a reference to the gem path that Homebrew chooses to use. And this then works regardless of your RVM or RBenv setup, and it always is using your system Ruby or the Ruby that you install via Homebrew. And as a bonus, we can use this mechanism to install also non-Ruby dependencies, so 1Password or kubectl and so on. And if you're interested in having that kind of setup, there are some examples in the Homebrew repository, so you can, for example, look at the Contena command line interface, how they are building this kind of stuff. Of course, with Homebrew as the default option, you could say that Linux support could be better. We have few people using Linux or non-Mac OS environments. Unfortunately, most of them, or even among the few people, they are choosing to use very different setups. So it's hard to justify the investment, or at least it doesn't make me very interested in such investment. And you can still use the DevBox tool, just symlinking stuff or installing the gem or something like that. So it's workable, but some manual steps are needed to have it running. There could be some nice solutions using a tool called FPM, which is short for effing package management, and that's their choice of, or how they spell it out. But basically it's a Ruby-based tool that allows you to build image packages for different operating systems, or especially Linux distributions. And because it's a Ruby-based tool, they also support, on some level at least, building operating system packages from Ruby gems. So that could work. I have tried to promote that idea to some of the Linux developers, but they have not yet been very interested. But that's something we have working. There are some future things we might want to use or take in use. So it might be nice if you wouldn't have to run the deploy all command on your laptop, but could instruct a service to do that, so that it sets up everything, and if there is something to be built or a Docker image that needs to be built, then the service would do that, and it could be a even more stable solution for the initial setup. I mentioned Helm and Scaffold earlier, though that could be a more standard replacement for Kubernetes deploy and telepresence. But then again, telepresence is working quite well for us, so I'm not sure. I guess it depends more on if we want to move from Kubernetes deploy to Helm at some point. And we would certainly like to open source DevBox. Unfortunately, there are some specific things in the code base still, which we would need to figure out how to have somewhere else for the open sourcing to make sense. And this, we probably should try to run DevBox against some public Kubernetes cluster like Google Cloud instead of just our own, to see if there's something we have missed in the process. That might also be helpful because the setup does have one caveat right now. It is surprisingly slow if you're not in Finland, because then the round trip between database and your service running on your local laptop grows. So that's something to take in consideration, that telepresence might not be optimal if you are not located close to the Kubernetes cluster, or especially need to develop all around the world your application. And I can show you a bit on how this works. Maybe if I get the... So if I would be using DevBox, probably the first thing I would do is to pull all the repositories and see if there are any updates. And there probably were not that many. It doesn't check out or change the branch if you are in some other branch than the master branch. So for example, here the Smarty UI and Smarty V1 repositories were not pulled, but all the others were updated. Then let's say if to deploy a service, I have actually deleted this one, so it now says that nothing is found. So let's deploy that. Because I'm creating the namespace, I need to get secrets from one password. If the namespace is not being created, that's not required. Then it outputs a fair amount of stuff to my screen. Now it's waiting that Kubernetes acknowledges that the process called web, or deployment called web, is running. Now it got confirmation that everything is there, so we can test again whether the service responds with something. And now it does say invalid batch, which is expected because I just made a dummy call. But that's something to, or how we can get a individual service updated. Since that worked quite well, now I can feel adventurous and try to update all my projects. So that would look which projects are not being updated, which in this case a project called Distillery has had some changes in the past I don't know, 3 hours. And that probably takes a bit longer to run than my example deployment, but should do the exactly same thing and end up in a consistent state. And now that I have the environment running, then I can access the development environment in my own subdomain. Oh nice, our CSS bug is back, or we are not loading any CSS. And I don't remember my password. That's going to be me. Maybe I destroyed the environment at some point.
Maybe it's password.
It could be because
I tried. You mentioned it was one password.
It has a hint that it's password, so that's a good.
Capital P. And one.
No, it's not. Well, I could create.
Maybe you lost your data and you need to back.
That might be.
What backup?
Unfortunately, our sign-up process is a bit complicated because, well, there's no other authentication in the development cluster, so please don't use this against us. But basically, if we had the sign-up open, thank you. If we had the sign-up open, oh no.
Yeah, we don't support unsecure passwords.
It's compromised.
What? What is this?
Compromised password, it's more serious.
Yeah, these security things are always annoying. And now it's loading my development instance, but of course it doesn't have any data because that's removed. And then I could demonstrate smartly, but I'm not sure how many of you would be interested in having a quick demo about Facebook ad automation. But that's
your recruitment speech. Are you also hiring?
We are also hiring, so if you're interested in building Facebook ad automation, or maybe the tools that helps others to build Facebook ad automation, we would be interested in talking to you. But that's pretty much how you could work with DevBox or get stuff running and have a complete independent environment, which is pretty much like having a staging for each developer. And there's an amazing testimonial by one consultant that was working for us that it's amazing that now my MacBook charges its battery when it's plugged in, which wasn't the case with the previous setup. So there was a limit to his working day length, at which point he just couldn't do stuff because he was out of battery and plugging it in wouldn't help.